When considering the idea of left and right approximations to the area underneath a curve, underneath a smooth or nonlinear curve, all of those two sums and anything of that general form are called Riemann sums in mathematics. And to generalize, if we think of what we saw before for left sum, especially writing in this form here, we had the sum from I equals 1 to n of f of x I minus 1 times delta x. And again, what our basic approach here was trying to find the integral under some curve, and we broke that interval, that long interval AB, into a bunch of subintervals, and then we named all the boundary points on those subintervals. We labeled those as x sub 0, x sub 1, and so on up to x sub n. So when we were looking at the left endpoints, we would use x0, we would use x1, x2, x3, all the way up to n minus 1. And the right endpoint estimate, or Riemann sum, would be built in almost exactly the same way. We would have I equals 1, but on the first interval we would use the other endpoint, the right endpoint. So when I is 1, we'd use x1. So that's how these relationships are built. Why is it I minus 1? Because when I is 1 to start with, we would use x0 as the height of a rectangle on the first interval. So we see that common pattern of a height times a width. And a Riemann sum is simply a generalization of that to say, well, as long as we get a height and a width, and we keep adding those up to get a sum in general, as long as we pick any point or some point, the whole point is it shouldn't matter really which point we pick, left or right or some other middle point. This would be x sub 1 star. Any one of those points could be x sub 1 star. It's not a great notation, I think, for students. I think it's more helpful to consider left endpoint, right endpoint, a midpoint, some strategically chosen point. The star, though, says that really you could pick any point you like at all on the first interval for x1 star. You could pick any point you liked on the second interval, left, right, mid, anywhere in between, to be, speaking of typos, to be x sub 2 star, delta x. And then on the third interval, you pick some point and then plug that into your function and get a height. That's all that this general formula here is indicating, is that sums of this form are all called Riemann sums. They're all trying to achieve the same objective of an approximation to the area underneath a graph. Again, here's that summary. They're all a sum of rectangular areas. They all involve widths and heights. And we're going to see some variations on the left and right rules later on that are also Riemann sums that, we won't need them in the long run for the most part, but they play an important role in numerical methods. So we'll explore them a bit later on.